Good afternoon, students.
Good afternoon, sir.
Okay, so today's topic is very important one. Why I have given this topic because I have seen that while discussing ANN, everyone skips this one. But this is the actually main focus that you have to give in case of ANN, that is activation function, right? I hope you have prepared this so you can present. So Ankit, please
Yes, sir.
start the session. Thank you.
Okay. Good afternoon, everyone. So today the discussion topic is about the activation function in the artificial neural network. So I will share my PPT first, then you can randomly participate in this discussion. Student, it is visible, right?
Yes, yes.
Okay. Okay. Guys, the two important thing is okay, if you understand the basic concept of artificial neural network, it is okay. Understanding the role that input layer, hidden layer, output layer do, it is okay. Like how it is do, that is more important. Um, that is the activation function. How it artificial neural network deal with the real world complex problem. That is the thing. Okay, just to give you summary that what we do first is we take the raw data in the input, then we do the computational part in the hidden layer, isn't it? So then we get the particular output. Okay, so I've covered three important activation function. There are more researches going on, and there is more researches going on in this particular algorithm to make it more generalized to solve more problem. So the first thing is that what we do is we try to solve we try to understand different problem in the we try to construct the um, solution in the hidden layer, isn't it? So when we artificial intelligence tackle with the real world problem, then the thing is that if we do not use artificial activation function, then it will be not properly cannot compete with the real world, isn't it? So artificial in the artificial neural network, activation function is used to perform the complex computation that is in the hidden layer. Fine, then it transfer the result to the output layer. The thing is that the main purpose of the activation function is to introduce the non-linear properties in the linear network, neural network. So if you use the linear function to solve the real world problem, maybe the output is not that what we want, and we don't want such output which do not give like a proper result or something. Fine. So what it do, activation function have to convert the linear input signal of the node into non-linear output. Fine. To give us the high order polynomials to understand the degree of the deep networks. Fine. And one more thing is that the artificial activation function is that they are differentiable. Okay. So the artificial neural network use activation function to perform complex computational in the hidden layer. So I mentioned this line here. So more thing are there. I have told that about the degree. So there are different types of degree, polynomial degree, isn't it? The degree one linear, suppose x plus 4, x plus 3. So higher degree, if you go to the higher degree, then it is like 2 degrees quadratic, isn't it? Suppose x square minus x plus 4, this one. So what okay, so there are two types, that is linear activation function, and the second one is a non-linear activation function. Okay, so here in the linear, you can see the graph. What is the output? What is the output? There is no range, isn't it? The output of the function will not be confined with any range, isn't it? So what will be the equation? fx equal to x, isn't it? The range is in minus infinity to infinity. Fine. So it doesn't help with the complexity, to solve the complexity in the neural network. What do is to we use for the complex computational, isn't it? So for the like more things are there, like if activation function are not applied, then what will be the result? First thing is that we will not get the output, we will get the output in a linear way, a linear function, isn't it? That is the polynomial degree of what? Polynomial degree, fine. And yeah, it is easy to solve a linear equation, but for the complex problem, it is not that much good. And the if artificial in the artificial neural network, if the activation function is not included, then what we will get the linear regression model, isn't it? And that is not we want. And the task of the neural network is to compute highly complicated calculations, like when we deal with complicated data, including image, speech, video, audio, etc. Fine. So linear activation function help the neural networks to make some sense of complicated, high dimension, and non-linear. So see, one more important thing is that some of the terms are there, like gradient. Um, each one of have its own advantage and disadvantage. If we perform practically, then we can say that disadvantage, like it is vanishing the gradient. And to understand the gradient, we must be a little bit familiar with the vector calculus. Fine. There is an open source book. There is mathematics of for machine learning. You can go through. Like it will help to perform the um, practical. By using the library, it is okay, but if you understand the particular graph, that how it is vanishing the gradient, then you will understand more. So here in this graph, you can see that the it is help the neural network to present the graph in like this something curve type. And so it will easy for us to generalize the data. Fine. So the next, the first activation function is like logistic activation function. Fine. You can see that in this graph, it look like S shape. So linear in nature, isn't it? It is a smooth gradient, and you can notice that suppose the x value is -2 to 2, then y value are very steep, isn't it? Which means that any small changes in the value of x in that region will cause value of y to change. And this means that the function has the tendency to bring the y value to either end of the curve, isn't it? And yeah, and the advantage is that unlike a linear function, the output of the activation function is always going to be in the range of 0 and 1, compared to the negative infinity to the positive infinity of the linear function. So it is good. Like sigmoid function are widely used, but still there is a problem, is that it vanishes the gradient. So what will happen, like if the gradient is small or vanish, then the network will refuse to learn. Okay, the network will refuse to learn. And to tackle this problem, there is still one more thing. Activation function is that there is tangent, hyperbolic tangent function, which range to -1 and 1. Fine. And it is similar with logistic sigmoid, but still there is advantages. The advantages is that the negative input will be mapped and the function is monotonic, while it derive in non-monotonic. Okay, so one more advantage is that it is zero centered. That is make it easier to model input to have strongly negative, neutral, and strongly positive value. So we can quickly derives of the tangent which are larger than the derivatives of the sigmoid. and it can also minimize the cost function. Fine. And the disadvantage gradient problem. Here also the same problem will occurs. And why actually derivation is used? Like when we the curve, it depends upon the slope. So that is the reason that we use in. So the next is rectified linear unit. So here the most rectified linear unit is the most activation function in the world right now, since it is used in almost in all the CNN or the deep learning. So here you can see that the rectified linear unit is half rectified from the bottom. There is the lower this one f, suppose you take this fx, it is 0, fine, and the z is less than 0, and yeah, it is the what will be the range, then it will be 0 to infinity, fine. And here the property is the function and its derivative, fine, but there is issue that all the negative value become 0 immediately, okay, without the decrease which decrease the ability of the model to fit or train for the data properly. That means that any linear unit activation function turns the value into 0 immediately in the which in turns affect the resulting graph by not mapping the negative value appropriately, isn't it? But there is advantage, like in computation, it's guarantee the faster computation, and it does not compute exponential and division, thereby boosting the overall computational speed. Okay, so to tackle this, one more activation function is there, that is rectified linear unit. I have not discussed, but if you take some sample and you can see that there is leak, then it will show the negative part, the negative graph. It will be plotted there, and it will show like yeah, there is a leaky is going on, and you can understand that, okay, fine, there is next step we can take to optimize this rectified linear net unit. So for better activation function, the research is going on. There are lots of it. There are like SOFTMAX is there, and lots of uh, activation functions are there used for some of the, by understanding the data, we use the particular activation function to work properly and get proper output. Fine. Since okay, so still, so thank you. Suryan, you can present next. हम्म, आ रहा है रुको. हाँ आ गया.
So let's start with what is activation function. So activation function defines the output of node that is given in the inputs. They basically decide to give get this output. It also offers a non-linear transformation on the input to get better results on complex neural network. Also help to normalize the out of any input in the range between 1 to -1. Because the neural network sometimes trained on millions of data points. The neural network activation function the most significant component of learning. It's fundamentally used for determining the output of deep learning models, its accuracy, and performance efficiency of the training model. That to scale neural network. What is the role of activation function? So in a neural network, numeric data points called inputs are fed in the neurons in the input layer. Each neuron has a weight, and multiplying the input over the weight gives output of the neuron, which is transferred to the next. To feed in the current neuron and its output going to the next. It can be as simple as a step function that turns a neuron output on or off, depending on a threshold value. Can signals in output signals that are needed for a neuron's network to function. Now, there are many types of activation. So a binary step function is a above or below threshold value. The neuron is activated and send exactly the same signal to the next value of zero, then fx value will be 1, and if the value of x is smaller than 0, then the fx value will next is the rectified unit. So rectified unit or ReLU is most widely used activation function, which ranges from infinite all the negative values are converted into 0, and this is so fast, then it can map not fit into data properly, which creates a problem. There is a problem, there is a solution also. That these are different activation functions that is known as key ReLU. Consider ReLU to is unknown. If key ReLU is expanded, the analysis is performed. Key not negative but value near to solve the major issue function. Then comes the Sigmoid activation function. This activation function is slightly better than the other one. Then, in order to map values to probability, use the Sigmoid function. Which maps a value into another value in 0 and 1. It is a probabilistic approach towards decision making. The value will be less than the value will be 0. If the value will be more than 0 and the value of the hyperbolic tangent activation function. Function is better than the function. And function is also better or different. But if a negative input to negative quantity, there is -1 and is 1 that's max function. The SOFTMAX function that is out here for the same as the according to the weight and sum of in the one for binary classification, both sigma and equally approachable, but classification problem is used for
Okay, next, Prince. Okay, Dhitiman, I think. Okay, Dhitiman Hazarika, please present.
Okay. Hello, Ankit. Is my screen visible?
Yes, it is coming with. Yeah, it is visible.
Okay. So good afternoon, everyone. So today I'll be talking about different activation functions related to ANNs, that are artificial neural networks. So basically, ANN uses activation functions for handling complex computations that are performed in the hidden layers and transfer the result to the output layer. The primary purpose of activation functions is to introduce non-linear properties in the neural network. So what it does is that it converts the linear input signals of a node into a non-linear output signals to facilitate the learning of high-order polynomials that go beyond 1 degree for deep networks. A unique aspect of activation function is that they are differentiable, that it helps them function during the backpropagation of neural networks. So basically, what is the need for non-linearity? As you can see, if we don't use activation functions, then the output signal will be simply a linear function that will be simply a polynomial of 1 degree, which will be easy to solve, but it will have limited complexity quotient. That means it will have less power for handling complex functional mappings from data. For that reason, if we don't use activation functions, so our ANN will be simply a neural network having a linear regression model with limited abilities. Now, I'll talk about different types of activation functions. The first one is sigmoid function. So sigmoid function is a non-linear activate activation function that is feed forward, that works on feed forward neural networks. It is a differentiable real function, and it handles real input values that contains positive derivatives with a specific degree of smoothness. It appears in the output layer of the deep learning models used for predicting probability based outputs. The sigmoid function is represented as you can see in the image below. It is defined as the function of x is equal to under bracket 1 divided by 1 plus exponential of inverse x. The derivatives of the sigmoid functions are applied to learning algorithms, and the graph of the sigmoid function is a S-shaped graph. But the major drawbacks related to this type of function is that it it suffers from gradient saturation, slow convergence, sharp damp gradients during back propagation from within deeper hidden layers to the input layers, and non-zero centered output that causes the gradient updates to propagate in varying directions. Moving on to the next activation function, that is hyperbolic tangent function. It is also known as Tanh function. So it is a smoother zero-centered function having a range between -1 to 1. The output of the Tanh function is represented by function of xi is equal to exponential xi divided by summation of exponential xj. The 10h function is extensively used than the sigmoid function, as it delivers better training performance and it works on multi-layer neural networks. So it produces a zero-centered output and it supports backpropagation process. The 10h function widely used for recurrent neural networks, and it is involved in real-time applications like natural language processing and speech recognition tasks. But the major drawback it suffers are that it is unable to solve the vanishing gradient problem, and the 10s function attain a gradient of 1 when the input value is 0. The function can produce dead neurons during the computation process. Moving on to the next, that is activation function, that is SOFTMAX function. The SOFTMAX function is used to compute probability distribution from a vector of real numbers. It generates an output that ranges between the values 0 and 1, and with the sum of the probabilities being equal to 1. The SOFTMAX function is represented as follows. It is given by function of xi is equal to exponential xi divided by summation of exponential xj. This function is mainly used in multi-class models, and it returns probability of each class with the target class having the highest probability. The primary difference between the sigmoid function and the softmax activation function is that the sigmoid function gives binary classification, while the softmax activation function gives multivariate classification. And next one I will talk about is SOFTSIGN function. The SOFTSIGN function is primarily a regression computational. It works on regression computation problems, and but nowadays it is used in deep learning based text to speech application. So it is a quadratic polynomial, and it is represented by function of x is equal to under the bracket x divided by modulus of x plus 1. Here x equals the absolute value of the input. The main difference between SOFTSIGN function and the 10s function is that the 10s function that converges exponentially, and the SOFTSIGN function converges in a polynomial form. And the next activation function is rectified linear unit, that is also called as ReLU function. So this is a fast learning activation function, and it delivers state of the art performance with stellar results. Now compared to other activation functions, the ReLU function offers better performance and generalization in deep learning. This function is nearly linear function and retains the properties of linear models, which make them easy to optimize with gradient descent methods. The ReLU function performs a threshold operation on each input element where all values less than 0 are set to 0. Thus, ReLU is represented as function of x equal to max, and the range is 0, x, which is equal to under bracket xi if xi greater than equal to 0, and the next option is 0 if xi is less than 0. The ReLU function guarantees faster computation and it does not compute exponential and divisions. Thereby, it boosts the overall computational speed. ReLU function introduces sparsity in the hidden units by putting the values between 0 to maximum. And the next one is exponential linear units that are also called ELU's function. The exponential linear units function, it speeds up the training of neural networks. The ELU function eliminates the vanishing gradient problem using identity for positive values and by improving the learning characteristics of the model. The exponential linear unit function is represented as function of x equal to x if x greater than 0, and alpha exponential x minus 1 if x is less than or equal to 0, and its derivative function is given by 1 if x greater than 0 and function of x plus alpha if x is less than equal to 0. Here alpha equals to the ELU hyperparameter that controls the saturation point for negative net inputs, which is usually set to 1.0. However, ELU has a limitation, that is, it is not a zero-centered function. So that's all for today. Thank you.
Okay, thank you, Didiman. So next, Santosh Kumar, you can share your slide.
Hello. Yes, Ankit, just a second. I'm sharing my screen.
Okay.
So, is this visible now?
Oh, yeah, it is visible.
So, good morning, everyone. So today's topic is activation function used in ANN. So let's start with what is activation function. So activation function are mathematical equation that determine the output of neural network. The function is attached to each neuron in the network and determine whether it should be activated, that is fired or not, based on whether each neuron's input is relevant for the model's prediction. So basically, activation function is a function that is added into an artificial neural network in order to help the network learn complex patterns in the data. When comparing with a neuron-based model, that is our brain, the activation function is at the end deciding what is to be fired to the next neuron. So that is exactly what an activation function does in an ANN as well. It takes in the output signal from the previous cell and convert it in some form that can take as input to the next cell. So it is also called as transfer function. What we sorry, it is why actually typing mistake. Why we use activation function with neural networks? So it is used to determine the output of neural network, like yes or no, by basically binary option. Like it maps the resulting values in between 0 to 1 or -1 to 1, etc., depending upon the function, that whether the function is linear or non-linear activation function. So there are basically two types of activation function, that is linear activation function and non-linear activation function. So let's start with the linear activation function. So as you can see, in this graph, the function is a line or linear, that is in a straight line. The output function will not be confined between any range, and that range will be from the minus infinity to plus infinity. And the given function equation you can see is f of x is x. It does not help with complexity or various parameters of usual data that is fed to the neural network. So you can see that the graph is always in a straight line or similar to a straight line. And in non-linear activation function are mostly used activation function. These are the mostly used activation function. You can see that the graph here is actually a curve like a slope, not in a straight line. That way it's called non-linear activation function. It makes it easy for the model to generate or adapt with variety of data and to differentiate between the output. So the main technology needed to understand for non-linear function are basically two key points, that the derivative, or you can say differential change in x-axis with respect to change in x-axis is also known as slope. You can see that in the graph, the line is going upward and then coming down like a slope. And in another case, monotonic function, a function which is either entirely non-increasing or entirely non-decreasing. So why do we need non-linear activation function? In a neural network without an activation function is essentially just a linear regression model, nothing. And the activation function uh, does not the non-linear transformation to the input, making it capable to learn and perform complex tasks. So that is the main use of non-linear function, and that's all for this. Thank you.
Okay, thank you, Santosh. Next, please, Prince Gogoi, please share your slide. Okay.
Is it visible?
Yeah, it is visible.
Good afternoon, everyone. So today's discussion topic is different activation function used in ANN. ANN is artificial neural network that is an attempt to simulate the network of neurons that make up a human brain so that the computer will able to learn things and make decision like a human-like manner. What is activation function? Activation functions are mathematical equations that determine the output of a neural network. Activation functions also help normalize the output of each neuron, a range between 1 and 0 and or between -1 and 1. Why we need activation functions? Without activation functions, weight and bias would only have a linear transformation, or neural network is just a linear regression model. A linear equation is polynomial of 1 degree, which is simple to solve but limited in terms of ability to solve complex problems or higher degree polynomials. So types of activation functions. The most famous activation functions are binary steps. This activation function is very basic and it comes to mind every time if we try to bound output. It is basically a threshold based classifier. Uh, in this, we decide some threshold value to decide output that neurons should be activated or deactivated. Second is linear activation function. Linear activation function is a simple straight line activation function where our function is directly proportional to the weight sum of neuron or input. Linear activation functions are better in given a wide range of activation, and a line of a positive slope may increase the firing rates as the input rate increases. Third one is ReLU, rectified linear unit activation function. Rectified linear unit is most widely used in activation function right now, which ranges from 0 to infinity. All the negative values are converted into 0 and This conversion rate is so fast that neither it can map or nor fit into the data properly, which creates a problem. And to solve this problem, we have leaky ReLU. So we can use leaky ReLU function instead of ReLU to avoid this unfitting. In ReLU function, range is expanded, which enhance the performance. And there's Sigmoid activation function. The Sigmoid activation function is used mostly as it does its task with great efficiency. It basically is a probabilistic approach toward the decision making and ranges between 0 to 1. So when you have to make a decision or to predict output, we use this activation function because the range is minimum. Therefore, prediction would be more accurate. Um, and then 10H, hyperbolic tangent activation function. This activation function is slightly better than sigmoid function. Like the sigmoid function, it is also used to predict or to differentiate between two classes, but it maps the negative input into negative quantity only and ranges between -1 to 1. And last, softmax activation function. Softmax activation function is used mainly in the last layer, that is output layer for decision making, the same as sigmoid activation works. The softmax is basically gives the value to the input variable according to the weight, and the sum of these weights is eventually 1. For binary classification, both sigmoid and as well as softmax are equally approachable, but in this Mm, thank you.
Okay, thank you, Prince. Next, please, Purabi Barasar, share your slide.
Good afternoon, everyone. Myself, Puravi Prasar. Today's discussion topic is different types of activation functions used in ANN. What is ANN? Mm, ANN are considered nonlinear statistical data modeling tools where the complex relationships between input and output are modeled or patterned are found. ANN takes data samples rather than the entire data sets to arrive at solutions which saves both time and money. What is activation functions? The activation functions of node defines the output of that node given an input or set of input. The purpose of activation functions is to introduce non-linearity into output of a neuron. Different types of activation functions. First one is sigmoid functions. It is used to used in output layer of a binary classification where results is either 0 or 1. As value for sigmoid functions lies between 0 and 1 only, so result can be predicted easily to be 1 if value is greater than 0.5 and 0. Hyperbolic tangent functions. It is used in hidden layers of neural network as its values lies between 1 to 1 hence this means the mean for hidden layer come out to be 0 or very close to it. Next one is softmax functions. It is used when trying to handle multiple classes. The softmax functions would squeeze the output for each classes between 0 and 1 and would also divide by the sum of the outputs. Next one is SOFTSIGN function. It is used in neural network computing. It is primarily in regression computation problems. It is also used in DL-based text-to-speech applications. Next one is rectified linear unit functions. It is used less. It is less computationally expensive than hyperbolic tangent functions and sigmoid functions because it is involved simpler mathematical operations. Exponential linear unit functions. It is used activation functions that is also used in speed up the training of neural networks. Thank you.
Okay, thank you, Puravi. Next, please, Sumon Roy. Please share your slide.
Okay, wait just 1 minute. Is my screen visible? Hello.
Yes, it is
Ankit?
visible.
Okay.
Yes, it
So
is
good
visible.
afternoon, everyone. So today's discussion topic is different activation function used in uh, artificial neural networks. So first, what is activation function? So an activation function is a function that is used in artificial neural network, which outputs a small value for small inputs and a large value if its input exceeds a threshold. In other words, an activation function is a gate that checks that an incoming value is greater than a critical number. So the main function of it is to introduce nonlinear properties into the network, and the nonlinear activation function will help the model to understand the complexity and give accurate results. So next, so first function is SOFTSIGN function. The SOFTSIGN function is an activation function which rescales the values between -1 and 1, and by applying a threshold just like a sigmoid function. The advantage is that the value of a SOFTSIGN is zero-centered, which helps the next neuron during propagating. So next one is ReLU, the rectified linear unit activation function. So rectified linear unit is most widely used activation function right now, which range from 0 to infinity. All the negative values are converted into zero, and this conversion rate is so fast that neither it can map nor fit into a data properly, which creates a problem. So third one is exponential linear unit. So the exponential linear unit function is an uh, if that is also used to speed up the training of neural networks, just like the rectified linear unit function. So the biggest advantage of the exponential linear unit is that it can eliminate the vanishing gradient problem by using identify for positive values by improving the learning characteristics of the model. So the next one is sigmoid activation function. The sigmoid activation function is widely used is that to do tasks with great efficiency. It basically is a probabilistic approach towards decision making and range it between 0 to 1. So when we have a make a decision or to predict an output, we use the activation function because of its range is minimum, therefore prediction would be more accurate. So the fifth one is hyperbolic tangent activation function. So this activation function is slightly better than the sigmoid function. Like the sigmoid function is also used to predict or to differentiate between two classes, but it maps the negative input into negative quantity only and ranges it between -1 to 1. So last one is SOFTMAX activation function. SOFTMAX activation function is widely used at the last layer, that is output layer for decision making, the same as sigmoid activation work. Softmax basically give values to the input variables according to their weight, and the sum of these weights are eventually one. So that was all about the activation function. So thank you.
Okay, so only the one more student, Nivir Goswami. Please share your slide.
Please do it fast because we already closed the time.
Yes, sir. So Nivir Goswami will be the last.
Ankit, is my screen visible?
Yeah, it is visible.
Okay. So good afternoon, everyone. I am Nivir Goswami, and today I will discuss on different activation functions used in artificial neural network. So at first, what is activation function? It is a function that is added into an artificial neural network in order to help the network learn complex patterns in the data. When comparing with a neuron-based model that is in our brains, the activation function is at the end deciding what is to be fired to the next neuron. It takes in the output signal from the previous cell and converts it into some form that can be taken as input to the next cell. Artificial neural network use activation function to perform complex computation in the hidden layers and then transfer the result to the output layer. The primary purpose of artificial function is to introduce non-linear properties in the neural network. They convert the linear input signal of a node into non-linear output signals to facilitate the learning of high-order polynomials that go beyond 1 degree for deep networks. An unique aspect of artificial function is that they are differentiable. Thus, this helps them functioning during the backpropagation of the neural networks. Now moving to the types or the variations of activation functions. The first one is the sigmoid function. The sigmoid function is a nonlinear artificial function used primarily in feed-forward neural networks. It is a differentiable real function defined for real input values and containing positive derivatives wherever with a specific degree of smoothness. The graph of the sigmoid function is S-shaped. The sigmoid function appears in the output layer of the deep learning models and used for predicting probability-based outputs. Now moving to the second one, the hyperbolic tangent function. The hyperbolic tangent function is another type of artificial function. The function is much more extensively used than the sigmoid function since it delivers better training performance for multi-layer neural networks. The biggest advantage is that it produces a zero-centered output, thereby supporting the backpropagation process. This function has been mostly used in recurrent neural networks for natural language processing and speech recognition. It is a smoother, zero-centered function having a range between -1 to 1 as a result. Now moving to the third one, the softmax function. The softmax function is another type of artificial function used in neural network to compute probability distribution from a vector of real numbers. This function generates an output that ranges between 0 and 1, and with the sum of probabilities being equal to 1. Now moving to the fourth one, the SOFTSIGN function. This function is another part that is used in neural network computing. Although it is primarily in regression computation problem, nowadays it is also used in DL-based text-to-text speech application. It is quadratic polynomial represented. And the fifth one, rectified linear unit function. The rectified linear unit function is a fast learning artificial function that promises to deliver state-of-the-art performance with stellar results. This function is nearly linear function that retains the properties of linear models, which makes them easy to optimize with gradient descent methods. Compared to other artificial functions like Sigmoid, this function offers much better performance and generalization in deep learning. Moving to the last one, the sixth one, exponential linear unit function. The exponential linear unit function is used to speed up the training of neural networks. It can eliminate the vanishing gradient problem by using identity for positive values and by improving the learning characteristics of the model. And these functions have negative values that push the mean unit activation closer to 0, thereby reducing computational complexity and improving the learning speed. This function is an excellent alternative to the ReLU function. It decreases bias shifts by pushing mean activation towards 0 during the training process. And with this, I'd like to end this discussion. Thank you.
Okay, so thank you everyone for participating.
Okay, thank you, Ankit, and all of you for actively participating. I think today's topic is very interesting, right?
Thank you, sir.
Yes.
Yes, sir.
Okay, Ankit, I have sent a mail regarding that outlier test. Please check it. Okay.
Okay, sir. Okay, sure.
Okay. Thank you, everyone. We'll meet in the next one. All right.
Thank you, sir.